This is Chris Kehmeyer. I'm a managing partner at Tuscany Capital, a technology venture fund focused on the blockchain space. After graduating from law school, I joined one of Europe's first internet service providers as general counsel. The successful $350 million exit of that startup in 2000 allowed us to create the first international venture fund focused on peer-to-peer technologies and web-based gaming systems. With the emergence of Bitcoin and smart contract platforms, our focus shifted to blockchain-based solutions. And after 4 years of supporting the blockchain startup community with seed capital and education, my partner and I formed Tuscany's first protocol fund in January 2018. As of today, the fund has performed more than 650 individual due diligences on companies building on blockchains, and we made more than a dozen allocations within the space. The following presentation provides an overview of the state of blockchain through the lens of our science-based approach to technology investing. A paper published in October 2008 under the title Bitcoin, a peer-to-peer electronic cash system, describes the time-stamped recording of hash transactions today referred to as blockchain technology. The release of software based on that white paper and its adoption by independent operators in 2009 created the first public blockchain. While the phrase blockchain technology is often used synonymous with the term blockchain by itself, successful entrepreneurs and investors understand that the former describes a type of encryption which by itself does not provide the properties which make blockchain superior to database and distributed ledgers. Bitcoin's monetary policy prevented it from becoming the electronic payment system the creators hoped it would become, a shortcoming which a still growing number of cryptocurrencies aims to address. However, as of today, no blockchain-based system has found significant adoption for payment purposes. As second-generation blockchains, such as Ethereum, enabled the rapid deployment of unique cryptocurrencies, startups developed a variety of new use cases for tokens, such as fiat currency pegs, utility, and governance tokens. However, with few exceptions, the use case for most cryptocurrencies is still primarily limited to an exchange mechanism against other digital assets, with daily trading volumes totaling more than $100 billion across some 300 exchanges and 7,200 coins and tokens. To understand the paradigm shift that blockchains introduce, scientific principles demand to establish its relevance for commercial activity from first principles. Before the introduction of electronic computing, physical bearer instruments, such as cash or checks, dominated business undertakings, and data was recorded on paper, stored in folders and filing cabinets, usually custodied by the owner at his place of business. However, the ephemeral nature of paper documents soon had businesses look for better technology. This is why shortly after the invention of database technologies in 1960, commercial activity in financial data began to be recorded in digital form only. Aside from the conveniences software provides, the data was still siloed and access was only available to permissioned local personnel. Databases also introduced a new spectrum of error types such as data duplication, human entry errors, and hardware malfunctions. The threat vector to information stored in databases increased dramatically with the exposure to networks, which ultimately for most systems included the internet at large. Blockchain-based solutions enable record-keeping functions resembling those of physical paper. They are digital bearer instruments. Like the internet, public blockchains may be used by anybody. They are permissionless. Entries on public blockchains cannot be manipulated without being observed. And like physical bearer instruments, such as banknotes, blockchain transactions cannot be undone by the party initiating a transfer and are considered immutable. While blockchain-based solutions affect many fields of business and government, we have identified 12 sectors where these systems will have the greatest impact in the foreseeable future. A common thread across these areas are siloed legacy technologies and layers of middlemen controlling access to assets and information. As you can see, these are some of the world's largest markets. The combination of market size and technology debt incurred by legacy companies serving these spaces provide blue ocean opportunities for startups that create faster, cheaper, and more resilient decentralized software solutions. As many early blockchain-based innovations are centered around the evolution of money, investors must understand the state of money as a product, its functions, as well as its use cases. Financial professionals and technologists frequently default to a textbook definition of money, which cites its functions as a medium of exchange, a unit of account, and a store of value. However, when the author published these requirements for money in 1875, he could not have known of 21st century digital technologies. If William Jevons was alive today, he would observe that 97% of current money only exists as database entries. As such, the default medium of exchange has become bytes. Unlike the commodity money of Jevons's days, digital money can in principle move at the speed of light. Banks and financial service providers today are employing database technologies and legacy networks to facilitate the two use cases of money, spending and lending. Spending is most often implemented as demand accounts, commonly referred to as checking accounts. If Bob wants to send Alice $100 from his checking account, he may instruct his bank to wire the funds to her account. His bank will update his ledger, and through correspondence with Alice's bank, her ledger will be credited for the amount. Depending on the time and day the wire was initiated, the process may take hours and in some cases days. Blockchain-based solutions can accomplish the same in seconds without fees or intermediaries. Currently, more than 100 digital wallets support the use of cryptocurrencies. Many of these projects allow the use of fiat money. However, fees to buy and sell digital assets make the use of these instruments for payment largely impractical. Furthermore, most reviewed startups in the realm of digital wallets are aspiring to comply with regulations aimed at financial service providers of the past. Aside from cost for licensing borne by these companies, procedures such as Know Your Customer questionnaires introduce friction to the onboarding of new users and increase the user acquisition cost. And while a small number of merchants are willing to accept cryptocurrencies for payment of goods and services, investors should not expect the widespread adoption of new units of accounts. This assessment is supported by our review of most digital wallets available today. The common feature of these solutions is the user interface converting the value of cryptocurrencies to a fiat currency. Users in the US will see the value of Bitcoin in US dollars, while users in Europe will see its value in euro. And Japanese users will see the translation of digital assets to their value in yen. This observation points to an important distinction. Where the use cases of money are lending and spending, its function is that of unit of account, or put simply, the language of value. As such, the widespread adoption of digital wallets for the purpose of everyday payments is likely dependent on the issuance of compatible legal tender by central banks. In most developed countries, money's use case of lending exceeds that of payments by a significant margin. Today, lending functions are achieved via various forms of deposit accounts. Switching costs in form of bank-imposed fees do not allow for instant and/or incremental exchanges between account types and their various custodians. This limited most lending opportunities to licensed institutions such as banks. However, decentralized finance solutions, referred to as DeFi, do not require the involvement of a middleman such as a financial service provider. The general open source nature of DeFi system and voluntary participation has led to an explosion of experiments creating new blockchain-based lending systems on a weekly basis. Since the beginning of this year, direct investments into DeFi systems has thus increased from less than $1 billion to currently over $10 billion. While decentralized finance technologies are still limited to digitally native assets and the early adopters of these systems, compatible government-issued blockchain-based currencies could open the space to general audiences or even mass adoption. The United States, Europe, and China are all officially exploring the implementation of blockchain-based currency. With more than 40 other countries researching or planning their own central bank digital currency, it is no longer a question of if fiat currencies will make use of blockchains, but when. An estimated 1.7 billion people worldwide does not have access to banking and depend on physical cash for all of their financial needs. Automated teller machines not tied to legacy account-based banking systems can convert banknotes into digital cash and thus play an important role addressing this underserved market. As of today, there are some 10,000 machines deployed worldwide that support the use of cryptocurrencies. While the main use is currently that of Bitcoin purchases via cash, applications using the same blockchain networks as these ATMs can readily fulfill most functions currently offered by financial service providers and banks. Cryptocurrencies, decentralized finance solutions, and most decentralized applications are made possible by a central blockchain innovation, smart contracts. A helpful metaphor for smart contracts is that of a vending machine. In the world of atoms, pushing a banknote into a vending machine might result in the automated dispense of a beverage. Similarly, a user may send a digital token to a smart contract, which in return dispenses the desired digital product. The product would have usually been deposited by the creator of the asset or the owner of the requested right. This often neglected distinction is necessary as the enforcement of rights frequently requires the identification of the previous and or new rights owner, while the direct transfer of blockchain-native bearer instruments, such as Bitcoin, requires no disclosure of the transacting parties. In a narrow sense, only these digitally native implementations can be considered digital assets, where external transfer requirements point to a derivative nature of the exchanged value, taking on the legal nature of a rights transfer. While the later friction today still prevents the peer-to-peer transfer of homes, cars, and other real-world products, blockchain-based solutions will over time reduce the need for intermediaries for most of these assets. While blockchain-based currencies represent the first digital bearer instruments, they are frequently designed to be fungible, resembling the interchangeable nature of banknotes and coins. However, in 2017, a new standard emerged on the popular Ethereum smart contract platform, allowing the creation of blockchain entries representing unique digital objects referred to as non-fungible tokens, or NFT for short. The option to create NFTs has since been introduced on several other blockchains and provides a wide variety of use cases. Gaming marked the first use case for NFTs. It allows developers to sell digitally unique in-game items which can be owned permanently by the buyer. As first mover, the publishers of CryptoKitties sold $12 million worth of digital assets in less than 1 year. Supply chains can benefit greatly from NFT solutions via the reliable correlation of shipped goods and digital entries, addressing database-related errors which affect 95% of all records today. Digitally unique art has been an early use case of non-fungible tokens, with examples of digital photography selling for as much as $1 million. Web addresses for the decentralized internet are currently sold as non-fungible tokens, allowing buyers to permanently own domains for the emerging Web3. As we will show in the following slide, a growing number of collectibles, such as trading cards, are making use of non-fungible token technology. Future NFT use cases currently discussed and or in planning are digital ownership documents such as car titles and deeds. This example of soccer trading cards shows that early adopters in some cases are willing to spend several $1,000s for a single NFT. More examples like this can be found on websites such as OpenSea. Identity is the complex topic, even or maybe especially when viewed from the technology investor's perspective. We analyzed more than 100 solutions claiming to perform identity management functions, both startups as well as large established companies, many of which resemble honeypots for personal identifiable data waiting to be exposed. Prominent scandals, such as Cambridge Analytica's identification and consequent manipulation of US voters with the help of user profiles collected by Facebook and other data brokers, has created widespread awareness for the need to protect personal identifiable information on the internet from unauthorized use. The projected global cost of verification data used for identity theft alone is estimated to exceed $25 billion this year. And while the lack of privacy had long been identified as the original sin of the internet, laws such as Europe's General Data Protection Regulation and California's Consumer Privacy Act only provide regulatory frameworks to address problems inherent to database solutions and those with access to information stored this way. The purpose of Web 1.0 social media personas and game avatars is that of profiling users, to target them either for advertising or otherwise behavioral changes. Viable Web 3.0 solutions will not only return control over personal data to the individual, but protect users from the excesses of attention economies. Efforts, sometimes summarized under the moniker self-sovereign identity, are key to the creation of an Internet of Value, enabling a myriad of new business opportunities for startups developing legal, government, and regulatory solutions. Already, government agencies are piloting biometric technologies with decentralized storage solutions, replacing credentials historically issued in paper form. A common complaint for participants in the so-called sharing economy has been the outsized share of proceeds going to middlemen. Centralized systems currently enable platform providers to set discretionary fees with little recourse for the participants providing services such as rights and accommodations. As with other companies offering convenient discount offers for the masses, the product is often the individual itself. While advertising companies ostensibly providing free search or social media services are selling their users' attention to the highest bidder, current sharing economy companies aim to sell participants' labor at an algorithmically set price most advantageous to corporate objectives. We are already witnessing the emergence of decentralized systems capable of displacing rent-seeking platform providers with self-governance systems. While the current examples of entire cities replacing legacy ride-sharing solutions with cooperative models are anecdotal, they nevertheless provide a model for an entirely new startup paradigm focused on addressing a central structural problem in legacy corporate models. Blockchains are often referred to as protocols. Like the original Internet protocols such as FTP, TCP, SMTP, and HTTP, they are open source and free to use by anybody. If using the SMTP protocol required postage, the cost for sending emails within developed countries would exceed the gross domestic product of that nation in a matter of days. Without the Voice over Internet protocol, most businesses would not be able to afford hours of video conferencing. Blockchain-based transfer protocols on the verge of enabling the same efficiencies and more for financial services, asset transfers, and the protection of individuals, their activities, and personal data. Together with decentralized bandwidth, data storage, and domain systems, blockchain startups are rapidly working towards Web 3.0. Corporations are legal constructs aiming to organize and satisfy a diverse set of interests, which may include operators, employees, clients, suppliers, shareholders, and governmental organizations. Most commonly, however, a corporation's mandate is the increase of shareholder value, making the interests of other parties secondary to this objective. While the resulting internal friction compounds inefficiencies observable in many centralized organizations, the inherent conflict is also at the center of negative byproducts across most commercial activities to date. An observable number of these externalities negatively affect the environment by polluting the air, land, waterways, and oceans. As outlined in a previous slide, many effects are more insidious and take on the form of social engineering as a service. Bitcoin introduced the concept of decentralized autonomous organization, or DAOs. In principle, DAOs are a collection of smart contracts which allow participants to organize in a decentralized way without the permissions needed for traditional corporations. This organizational structure also allows for the alignment of interests of all network participants. Overly rent-seeking middlemen are unlikely to be tolerated by network participants, as the open-source nature of these systems enable rapid reorganization. While the Bitcoin blockchain constituted the first practical DAO, more of these organizational structures are likely to instantiate across many verticals, with frameworks such as Aragon already being built, potentially making the concept of DAOs long-term the most significant innovation of blockchain. By now, you should have come to the conclusion that blockchains are a larger paradigm shift than the first version of the Internet and provide knowledgeable investors with never-before-seen opportunities. However, if you want to learn more about concepts such as DAOs, please see my July 2018 article on Forbes.com, where you will also find my publications on non-fungible tokens, cryptocurrencies, and other blockchain-related investment topics. For extended versions, please find me on HackerNoon. Finally, if you have any questions, please feel free to connect to me on LinkedIn or contact me directly via the information on your screen.